My name is Eric Matlis. I'm an associate research professor here at the University of Notre Dame in the Aerospace and Mechanical Engineering department. My specialty is experimental fluid dynamics. I do a lot of wind tunnel testing. We're uniquely suited here at the University of Notre Dame to do wind tunnel testing. We're one of the most preeminent labs in the country for wind tunnel testing in subsonic and supersonic and hypersonic Mach number conditions. This facility is unique for the size and the speed that can be attained. It's a Mach 0.6, so it's subsonic. It has a 3 foot by 3 foot by 9 foot test section. It was designed to be the largest test section in the country at a university setting to be able to achieve a Mach 0.6. This is a very useful capability for the development of experimental aircraft. In fact, last summer I assisted in the design of an air mobility taxi eVTOL design for a small company in testing of their airfoils for their wings and propeller systems. And this facility was specifically sought after by this company due to the large size, which gives you realistic Reynolds numbers and realistic flow conditions that are difficult, if not impossible, to achieve at other universities. So they came to Notre Dame specifically for this facility, and I had a great time working with this company to do that research. The facility is a closed return facility, which means that the flow circulates in a loop. It's driven by a very large fan on the far side, which is driven by the largest AC induction motor on in this side of the state of Indiana. It's an 1,850 horsepower motor. That kind of power is needed to accelerate the flow to Mach 0.6. It generates a tremendous amount of heat in the flow, so we use a very large chiller system to keep the temperature under control, which is designed to cool the air through fins in the wind tunnel so that we can maintain a constant set of temperature and pressure conditions for an hour or more as we run this facility. The facility is controlled remotely through this control panel, and we have a coordination between the control system and a graduate student who might be sitting here taking data. So this facility is operable or available to graduate students to use for their research. We do have 3 different test sections so that we can support multiple experiments. You see a test section that's currently in place, and then we have an example of a second test section, and over this way a third test section. And these, as you can see, are very large, as I say, 3 foot by 3 foot by 9 foot, large windows to give optical access so that you can do experiments with laser-based systems, to do imaging and many different kinds of experimental techniques to either visualize the flow or to take measurements in the flow. We use these facilities extensively in the research that we do here at Notre Dame. I think with that, you'll find that very few universities offer a similar capability, and we're extremely proud of the capabilities that this facility gives us. Thank you.